How many hydrogens are present in this alkene? 2,3-dimethylpentene. The two best tips I can give you that helped me was to read the words backwards, read the name backwards, and make sure that the number of carbons in the name matches the number of carbons in the picture. So let's read this backwards, draw it, and then count the hydrogens. Pentene, that's going to be 5 carbons. I'll draw it this way as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It is pentene 2. So that means on the 2 carbon, there's a double bond. So the second carbon, first, second, dimethyl. That means that there's going to be 2 methyl groups, and methyl tells us, the meth tells us how many carbons, and the il, the YL, tells us that it's a substituent or an ornament to our parent carbon chain. So our parent carbon chain is these 5 carbons, and on the second and the third carbon, there is a methyl group. So on our second and our third carbon, there is a CH3, because that's what a methyl is. And then down here, put it as well. So see how this structure, now we read it backwards. Now let's make sure that the number of carbons in the name matches the number of carbons in our picture. Pentene means 5. And then it says dimethyl, so that is 1, that's 2 because methyl. So that means that there should be 7 carbons in our picture. 1, 2, 3, 4, 5, 6, 7. Yes. And this picture here, which 1, 2, 3, 4, 5, 6, 7. This question wanted to know the number of hydrogens that are present. Let's draw them in. Carbon bonds 4 times, so this carbon can take on how many hydrogens? This carbon can take on how many hydrogens? It's already done. Can't take on any more hydrogens. It's bonded 1, 2, 3, 4. This carbon is also done, and we have 3 up here from the methyls. This carbon can take on dos. This carbon can take on trace. Carbons bonding 4 times is crucial. This picture, this stick figure, we explicitly leave off the hydrogens and we don't draw the C's because we're just lazy here. This is a model of the same structure, 2,3-dimethylpentane. We have pentene. We have the double bond in here. Note the rotation that cannot occur around that double bond. And note the rotation that can occur around the single bond, okay? The pentene, the 5 carbons, is not a zigzag up and down. It's kind of got this kink in the chain, so to speak, because of that double bond. I hope this helps. Thank you.